What's up, guys? In this video, what I want to do is show you how to factor a trinomial without using substitution. Now, I love using substitution, but I also know that a lot of times substitution is pretty confusing for students. They don't really know what to use for substitution. They're like, what should I do? Should x to the 6th equal u? Should it equal u squared? I don't know. Like, it gets confusing. And I totally get it. I totally get it if it is confusing because, doing substitution, like any kind of mathematical skill, just comes with some practice. And it comes from a wide variety of different types of problems because in reality, like, we're not always going to be using the same value for substitution, right? We're going to be using different expressions and different types of problems. So the more practice you get, the better, the easier substitution is going to come. And substitution is an extremely important skill that I think you should know and should have to rely on. However, if you need something to do and you're like, I don't know how to use substitution in this case, what I want to do in this video is just show you a different way to approach the problem. And the way that I like to approach this problem is say, all right, this is a trinomial. And one thing I know about trinomials is I can factor quadratic trinomials. So what I'm going to do, without even trying to think about substitution, which maybe might get me confused, I'm going to say, you know what? I'm just going to rewrite this like an x squared problem. I don't know if it's right. I'm just going to do it. OK, so again, I'm just going to say, you know what? Let me just focus on factoring this real quick, see if this actually is something that's factorable. And then I'll try to see, all right, can I maybe go and apply my understanding of factoring to this problem based on this? OK, so hopefully we know this. We know all quadratic trinomials can be rewritten as a product of two binomials. OK, and we know the first two terms are going to multiply to give us an x squared. And we know the last two terms are going to multiply to give us a -7, and then they add to -6. So say that means one has to be positive, one has to be negative. Since my middle term is negative, that means my larger of my factors has to be negative. So that's going to be a -7 plus 1. So that is the factored form on that. Now this looks very similar to that, but it's not the same. But you know what? Who cares? Let's just go ahead and write it out. OK, because now what I want you to do is I want you to understand something. When I'm looking over here, the first two terms, right? The x times x gives you x squared. In this case, I need to say what two numbers multiply to give me an x to the 6th. Now again, we want these numbers to be exactly the same. Now again, remember the rules of exponents. So when I'm going to be multiplying two exponents, I'm going to add the powers. All right. So again, what two numbers that are exactly the same are going to add to give me a 6? I don't want to do like 5 and 1. I want them to be exactly the same. And I'll show you why they have to be exactly the same. Well, hopefully you recognize that has to be a 3. OK, so are we done? Well, I don't know. Let's go ahead and check our work, right? And here's the cool thing about factoring, guys. You can always go back and check your work. So if I was to multiply an x cubed times an x cubed, that's going to give me an x to the 6th, right? Add the powers. OK, now let's go and multiply here. X times 1 is going to give me an x cubed. A 7, or -7 times x cubed is going to give me a -7x cubed. And then we have a -7 times a +1 is going to be a -7. Now, if you chose, let's say, a 5 and a 1, or a 4 and a 2, or whatever else may be the case, you wouldn't be able to combine these. That's why it's important that these two powers have to be exactly the same. All right. And again, if they couldn't be exactly the same, like let's say it was x to the 7th, then you couldn't factor using this method. It wouldn't work. But now these are exactly the same. I know I can combine them, right? So therefore, now I'm going to get a x to the 6th minus a -6x cubed minus 7. And voila, you can see that we went back. We checked our answer. We got back to the original equation. Now, the only other thing that I want you to recognize here is you could further factor these down. And that's going to be going by using what we call the sum and difference of two cubes. So the simple problem would be like if I just said factor this into product of two binomials, then this would be your answer. But if I said like factor completely or as a list of prime factors, then we could go one step further down over here. OK, so the formula here for the sum and difference of two cubes, notice the plus or minus, doesn't matter if you're adding or subtracting. But when you have a cube number minus another cube number, you could rewrite this as a plus or minus ab times a squared plus ab plus ab squared. So these are both two cube numbers. This one is technically, we have an x cubed, but we have the -7 is not really a cube number. But we can still go ahead and factor that out. However, that wouldn't give us a rational power, though. Or that's going to give us a rational power. So I'd actually leave that exactly where it is. But here, in this case, I can actually simplify that. I can multiply that out. So if I would leave this here because what you want to do is take the cube root of these terms. Oh, actually, never mind. That's a number. So therefore, that will work. All right, so now let's go ahead and rewrite this out. And again, notice to get to my a, I need to take the cube root of this term and the cube root of that term. So x minus the cube root of 7. And then what I'm going to do is I'm going to square that. Now, again, you could use rational powers, but in this case, I'll just use a parenthesis here. OK, that is that factored form. And then here I can factor this one down by, again, just using, now this one is nice because I can take the cube root of these. So therefore, that's going to be a x plus 1 times a x squared plus x plus a 1 squared, which is just going to be 1. So there you go, ladies and gentlemen. Not sure if you need to factor this completely, but if you do too, there's a little bonus for you. Now in this example, I decided not to use substitution because I think it was kind of intuitive just to use factoring the way that we know how to use factoring. In the next one, you're going to want to use substitution because it's going to be a trinomial with exponents. I'll see you there.